So we're now working question 2 from the June 2018 paper, and it says factorize completely each of the following expressions. And by now, if you're practicing, it will be easy for us to identify certain stuff. So when we look at part 1, what we know is that this will eventually work out to be the difference of 2 square. Very good. So therefore, what we'll have is 1 minus, and we're changing the 4h square to a complete square. So what it will have is 2h in bracket, and that is raised to the second power, which makes it this expression now the difference of 2 square. And what we know is that when we're looking at difference of 2 square, when we're factorizing the difference of 2 square, it is basically having each expression in a bracket, and one bracket have a plus sign and the other has a minus sign, and that is all we're doing when we're looking at the difference of 2 squares. So what we'll have is 1 minus 2h in one bracket, and in the other bracket 1 plus 2h. And that is what you're doing whenever you realize that something that you're factorizing will work out to be the difference of 2 square. So we're looking at this, we know that the only way this could have worked is by finding the difference of 2 square. So we change the 4 to a squared number as well, and we have the 2h square, and it just works out to having each term, which is the 1 and the 2h, in 2 separate brackets. One have a subtraction sign, one have an addition sign, and this is your final answer. Now working part 2, which I've seen some persons already got the answer. We're doing this now by grouping. So what you're going to do is to put 2 terms. Usually can put 2 terms in bracket that where there is a common variable in each. So from pq minus q square, so from this right here, what is common is p, and what we know is that, what is common is q, and what is common goes on the outside. So what we'll have is q into pq will leave us with p, and the q into a negative q square will leave us with minus q. And then we have for the second portion, which is the minus 3p plus 3q, what we're using as our common factor is minus 3, and we're saying minus 3 into minus 3p will leave us with a positive p, and minus 3 into a positive 3q will leave us with a minus q. And what we do here, theory states that we're factorizing again, but what I love to say to students is basically we're writing back what is in bracket, in a bracket by itself, so p minus q, and in the other bracket we're writing the common factor, the terms that are on the outside, which is q minus 3. So this is our answer, p minus q and q minus 3. And for those who are wondering, no, it doesn't matter the order that you wrote it in. So if you had q minus 3 in front, then p minus q at the back, then your answer is still correct. Because no matter which order you write it in, should you work this answer out, you'll still arrive back at the original question that was given. Part B now says, which someone brilliantly already got the answer, is 3 over 2y is equal to 12. So I usually work this is by finding the LCM and then using the LCM to multiply by each term in the equation. So in this case, our LCM is 2, so I'm going to multiply 2 by each term. So 2 multiplied by 3 over 2y is equal to 2 multiplied by 12. So we're multiplying the LCM by each term in the equation. So for right here, this 2 can cancel with this 2. So what we have remaining is 3y is equal to 2 multiplied by 12, and 2 multiplied by 12 will give you 24. Yes to that question, you can work it that way as well, and you'll still get the same answer. So now we have 3y is equal to 24, and we're now solving for y. So y is equal to 24 divided by 3. And when you do 24 divided by 3, you will get y being 8. If you're wondering how the 3 is being divided here, we're trying to get this 3 from the left-hand side beside the y to the right-hand side. The only way we can do that is by dividing both sides of the equation by 3, and what we'll have remain is y is equal to 24 divided by 3, and therefore y is equal to 8. How do I know that my answer is correct? Should I now substitute y for 8 in the original equation? Then you'll get both sides of the equation being 12. So when you do 3 divided by 2 multiplied by 8, you will see that you get 12. And that is how I know that my answer is correct. Part 2 now, which some persons have brilliantly solved. Is quadratic equation. So basically now factorizing using quadratic. So what we have is, so what we know is that when we see this, we know that our A term is 2, our B term is 5, and our C term is -3. Let me just go ahead and do the full teaching to ensure that everyone understands. So we know our formula for quadratic is AX plus BX plus C, which is equal to 0. Or A terms, if we line this up under this equation, or A would be equal to 2, or B would be equal to 5, and or C would be equal to -3. So when we're solving quadratic, we're first trying to find the AC term, or AC term would be 2 multiplied by -3, which is equal to -6. So in solving quadratic equations, what it wants from us is that we find two numbers that when we multiply, we get the AC term, and when we add, we get the B term. Yes, go ahead.
When you're doing that question, basically, you have to use the formula thing that I see, right? AX plus BX plus C equals 0.
I'm not using the formula, I was just showing you how to identify the different terms. So
Okay.
what is important is this, because you need to find the AC term, which is -6, which you necessarily don't have to write, but I'm just breaking it down to show everyone. Because what we now need to know is how we're going to get the two terms to replace 5x. We get the two terms to replace 5x by finding which two numbers, when we multiply them, will give us -6. So we got the -6 by multiplying the AC term, which is 2 and -3. So we're finding two terms that when we multiply them, it will give us -6. And at the same time, when we add those two numbers, it will give us our B value, which in this case is 5. And the two numbers that we're going to use is a +6 and a -1. So that will be 2x squared plus 6x minus 1x minus 3 is equal to 0. So when you find that two term, you're going to replace it with the middle term, and then this is where your factorization begins. So the two terms would be 6 and -1. When we multiply 6 by -1, we get -6, and when we add 6 plus -1, we get a +5, and that is the criteria for us to now go ahead and factorize. So now we can factorize the first two terms, 2x squared and 6x, and what is common here is 2x. So we can say 2x into 2x squared will leave us with x, and 2x into 6x will leave us with 3. And then for these last two terms, it will be -1 into a -1x will leave us with a positive x, and -1 into a -3 will leave us with a positive 3. Remember that when you divide a negative number by a negative number, your answer is positive. And again, just as before, what we do now is to put our terms in bracket or factorize again. So we have 2x minus 1 in one bracket, and in the other bracket, x plus 3, and that is equal to 0. And if you're wondering what the persons were putting in the chat, if it looked familiar, this is where now you find the two values that are possible for x. So what we have is 2x from the first bracket, 2x minus 1 is equal to 0, or x plus 3 is equal to 0. And now I'm going to solve for both x values. So what we have is 2x minus 1 is equal to 0. So therefore, 2x is equal to a positive 1, as the 1 was subtracting on the left-hand side. So when it comes across, it will be adding. So we're adding 1 to both sides of the equation. And now we have x is equal to a half. And this is our first x term. And the other one was x plus 3 is equal to 0. And this was a simple one. So x is equal to -3. So therefore, x is equal to a half, or x is equal to -3. And that was our two possible solutions for x. Part C now says the quantities FMUV, and is a formula for force, and the T are related to the formula where force is equal to multiply by V minus U over T. So part 1 asks us to find the value of F when M is equal to 3, U is equal to -1, V is 2, and T is equal to 1. So what they're asking us is to basically substitute. So what we have is the value for M is 3, and then in bracket what we have is V minus U, which is 2 minus a -1. And all of that is divided by T, which is 1. So what you're going to do is to first work out the bracket part. So what we have is this part here, negative multiplied by negative, will leave us with a positive sign here. So what we'll have in this bracket is 2 plus 1. So what it will be is 3, and then in bracket 2 plus 1, and all of that is divided by 1. So guys, all we're doing is substituting the values that they gave us in the question and putting it into the formula that was also given. So now working the bracket, 2 plus 1 is 3. So what we'll have is 3 multiplied by 2 plus 1 is 3, and all of that is divided by 1. So therefore 3 multiplied by 3 is 9. So therefore F is equal to 9 divided by 1. And when you do that working, what you'll get is F is equal to 9. So again, guys, they gave you the formula. So all you're doing is substituting each letter, each unknown variable by what they gave you. So they gave you that M is 3, u is -1, 2 is v, and t is equal to 1. We substitute into the formula and then solve for f, and we got f to be 9. So part 2 now asks us to make v the subject of the formula. So what we have is f is equal to m multiplied by v minus u, and all of that is divided by t. And this is the original formula. For those who are wondering, I did not make this up. This is what was at the top of the page. This is what they gave us in the question. And we are now making v from this the subject of the formula. So what we're doing first is expand the bracket using distributive law. So we're multiplying m by each term. So what we do is m multiplied by v, then m multiply by u. So what we have is f is equal to, so what we'll have is m multiplied by v will give us mv minus m multiplied by u will give us mu, and all of that is divided by t. What I'll do next is to multiply each side by t. So we're trying to get rid of the t that is currently on the right hand side divided. To get rid of it, we'll multiply each side of the equation by t. So what we'll get is ft is equal to mv minus mu. So we got rid of this t by multiplying each side of the equation by t. So it just looks something like this, multiplying each side by t. So if we multiply this side by t and multiplied this side by t, we get ft here, and this t cancels with this t, and that is how we get ft is equal to mv minus mu. Very good to that last answer. That is it. So we now have ft is equal to mv minus mu. What we have is, since we're solving for v, it means that we need to get rid of the mu. So we're going to add mu to both sides of the equation. So what we'll have is ft plus mu is equal to mv. For those who are wondering, we added to both sides. Yes, indeed we did. We did. So to this side we did plus mu. So therefore minus mu plus a positive mu will basically cancel out. So all we have remaining on this side is the mv, and we added the mu to this side as well. And that is how we got ft plus mu is equal to mv.
Question.
Go ahead.
Why did you use mu to divide both sides right here?
I didn't divide both sides by mu. I add both sides by mu. Remember, the mu is subtracting here. So in order to move it from the right-hand side of the equation to the left-hand side, I'll need to add it, or to get rid of it from the right-hand side, I need to add it to both sides of the equation, which is the same as saying it is a negative mu on the right-hand side. So if I'm moving it across the equal sign, the operation will change. It will now be doing the opposite of what it was doing on the other side. So it was subtracting on the right-hand side. So when it goes across the equal sign, the operation is now doing the opposite thing. So it is now adding on the left-hand side. Any better?
Yes.
Okay, good. So that is how we have ft plus mu is equal to mv. And now we're making v the subject of the formula. So the m is multiplying with the v here. So therefore we need to divide both sides of the equation by m. So what we have is ft plus mu, and that is divided by m, is equal to v. And yes, we did. Yes. So we did mv divided by m here, and ft plus mu divided by m. So this basically cancels out with this m here. So what we have is ft plus mu divided by m is equal to v. And that is how we got our final answer.
Sir, can I ask a question, please?
Go ahead.
Sir, did you have to start with the first procedure by multiplying m with the stuff in the brackets with b and u?
Yes.
Sir, suppose you don't do that. You'll get it wrong.
When you
I-
did you and you got the same answer?
Sir, I got ft plus u over m.
Exactly. You realize there's an m missing from up top. Because now, when you rework to make back f the subject of the formula, because you see this right here, what they did right here, was to factorize basically. Because when you rework from what you got to make back f the subject of the formula, you will not get the same thing here. You will not get f is equal to m. You basically in the end you will not be able to factorize, because this m being multiplied by the v minus u is the same as the mv minus mu. But what you did was to
Multiply t first.
What you only have is ft plus u. So in the end, you are missing some variables. So you'll not get back the original formula, which is the f is equal to m multiplied by v minus u. So if you get me.
All right, thanks.
And that is it for that part of the question. And this is it for question 2.